I am Mario Diaz from Universidad de Laguna in Spain. I can define myself as an enthusiastic scientist, a hard worker, and especially an admirer of multidisciplinary approaches. I'm totally embraced to science, but to good science. You see, after my doctorate, I moved to the Institute of Animal Physiology and Genetic Research in Cambridge, where I learned much about very relevant scientists in the fields of physiology, some of them even Nobel Prizes. I got a chance to be promoted as a senior scientific officer for the cancer research campaign in Oxford several years after, and I was there completely introduced in the field of breast cancers. When I moved back to Spain, I established the Laboratory of Membrane Physiology and Biophysics, and I became full professor of animal and molecular physiology in 2010, which is my current position. Nowadays, I am an active member of the editorial board of more than 10 international journals that are devoted to basic and applied physiological research. In the period 2010 to 2020, I worked for Frontiers in Membrane Physiology and Membrane Biophysics, of which I was the specialty chief editor. And in 2010, more or less the same time I was the specialty chief editor, I was offered a position as a director of an associate research unit between the National Research Council and Universidad de Laguna under the name of Membrane Physiology and Pathophysiology in Cancer and Neurodegenerative Diseases. In the last 2 decades, our laboratory has focused in two main research areas. The first one is based on the study of the physiology and pathophysiology of lipid raft, which are multimolecular complexes involved in a number of signaling pathways and also in intercellular communication, both under normal and diseased conditions. The second is devoted to the design and synthesis of novel tamoxifen derivatives as selective estrogen receptor modulators, which behave as antagonists of estrogen related proliferation. These compounds have proven to be particularly interesting because the emerging properties they exhibit. In particular, they behave as laser dyes in the sense that once they are excited above a certain energy, they behave as laser compounds capable of displaying spontaneous laser emission. And we have used this property to incorporate a novel functionality to the conjugates. In this case, in the case of FLTX2, we have incorporated a photosensitizer moiety so that the stimulation of FLTX2 causes a massive reactive oxygen species generation that produces oxidative stress in the cells where the anti-estrogen is bound. This very promising project and is being developed to further improve the specificity of the conjugate for metastatic proliferative cells. I want to finish this presentation by deeply thanking to the organizers and the selection committee of this International Award on Oncology and Cancer Research for considering my work and the work from my laboratory as a potential candidate for the obtention of the Best Researcher Award prize. Thank you very much.